In this video, I am going to tell you how Elon Musk's SpaceX is revolutionizing space industry. If we look back in time, ships cut the cost of crossing oceans. Railroads slashed the price of moving goods across continents. Airplanes shrank the world into a global village. And now, rockets are joining that list. For most of history, going to space cost hundreds of millions of dollars per launch. Space was a playground for governments, not businesses. But in the past decade, one company changed the economics of space forever. SpaceX took rocket costs and drove them down by a factor of 10. That's not just an engineering feat. It is the foundation of $1 trillion economic revolution, one that could transform industries on Earth and create entirely new ones in orbit. Before SpaceX, rockets were like disposable lighters. You built them once, lit the fuse, and threw them away. Imagine if every time you flew a plane, you had to throw the jet into the ocean afterwards. A single ticket would cost millions. That was the reality of spaceflight. Take NASA's space shuttle, for example. It was partially reusable, but still cost nearly $1.5 billion per launch once you factored in the workforce and refurbishment. The shuttle was a technological marvel, but an economic disaster. Meanwhile, conventional expendable rockets, like the Delta IV Heavy, often ran $400 million per launch. That price tag put space firmly out of reach for private industry. Only governments could afford it. That's why, for decades, the number of satellites in orbit grew slowly. The cost barrier was simply too high. Elon Musk looked at this and asked a childlike question. Why can't rockets be flown like airplanes? His guiding principle was deceptively simple. Rockets must be reusable. But the path to that goal was littered with explosions, setbacks, and near bankruptcy. Falcon 1, the first rocket, failed 4 times before a successful launch. Each failure was fiery, costly, and public. Yet with every failure, the engineers learned, iterated, and pushed closer to a solution. Then came Falcon 9, designed from the ground up for reuse. With 9 clustered Merlin engines, a robust first stage, and an advanced guidance systems, it promised the impossible. A rocket that could launch, return, and fly again. But when a rocket launched, the first stage, which is the largest and most powerful section, equipped with large engines and fuel tanks, is designed to lift the vehicle off the ground and accelerate it through the atmosphere. Once its fuel is exhausted, this stage detaches from the rocket, dropping away to make the remaining vehicle lighter and more efficient for the next stage to continue the ascent into space. Instead of throwing the most expensive part away, SpaceX engineered it to land itself, sometimes on a pad, sometimes on a drone ship in the middle of the ocean. It was audacious. The early tests ended in explosions. Even experts said it was impossible. But in 2015, SpaceX nailed the first landing. By 2017, they relaunched a used booster. And today, some Falcon 9 boosters have flown more than 20 times each. The impact on costs was immediate. A Falcon 9 launch lists at around $62 million. Spread over multiple flights, the marginal cost per launch drops to as little as $20 million. That's a 10 times price collapse compared to the $400 million rockets of the past. And suddenly, space was no longer the exclusive domain of superpowers. It was open for business. But the real question is, how could anyone design a rocket so flawlessly engineered? In the end, it all came down to 4 critical engineering innovations. 4 leaps that made the impossible possible. Number 1. Grid fins and precision landing. A Falcon 9 booster falls faster than a speeding bullet. Without control, it would tumble to its death. To tackle this, Falcon 9 has grid fins. Giant titanium waffles that snap open and bite the air. Like steel feathers, they steer the rocket with razor precision, adjusting hundreds of times per second. Guided by sensors, GPS, and bursts of cold gas, the booster doesn't just fall. It flies backward, correcting every wobble until it hovers above the landing pad. From Earth, it looks impossible, a skyscraper of fire balancing on its own exhaust. But without those fins, this ballet would end in chaos. Number 2, Merlin engines and reliability. At the core of every Falcon 9 stand 9 Merlin engines roaring in unison. Each one packs 190,000 pounds of thrust, yet they're not delicate showpieces, but rugged workhorses built cheap, simple, and fast. SpaceX didn't chase perfection. They chased reliability. By mass-producing Merlins like car engines and clustering 9 together, they created a rocket that can lose one mid-flight and still push onward. It's the opposite of NASA's shuttle, where 3 exquisite engines, so complex that they demand months of care after every launch. Number 3, rapid refurbishment. Picture this. You launch a 14-story rocket, torch it on re-entry, then slam it back onto a landing pad. NASA's shuttles took months to fly again, thousands of tiles to inspect, parts replaced by hand. It was like rebuilding a race car after every lap. SpaceX treated it like a pit stop. Heat-resistant paint, engines built like Lego, inspections cut to fast checklists. The result? Rockets flying again in weeks, sometimes under 10 days, lined up in hangars like trucks at a depot, ready to roll. They stopped being monuments, they became tools. Number 4, autonomous drone ships. What about missions where the rocket can't fly back to land? That's where SpaceX got truly creative. They built giant floating landing pads, drone ships the size of football fields, each with names borrowed from science fiction. Of course, I still love you, and just read the instructions. Parked in the middle of the ocean, these ships wait like steel islands. From hundreds of kilometers away, the booster begins its automated ballet. No pilot guides it, no tugboats help. The rocket, guided by onboard AI, streaks through the clouds, reignites its engines, and steadies itself over a rolling deck. The landing zone is tiny compared to the vast sea. The rocket leans against wind, waves, and Earth's rotation, but still it touches down, perfectly centered on the painted X. For decades, landing a rocket at sea was pure science fiction. Today, it's routine, a YouTube live stream watched by millions. Cutting the cost of space launches isn't just about saving money. It changes everything. It's like the difference between owning a private yacht and buying a plane ticket. Suddenly, space isn't reserved for billionaires or governments. Now, anyone with vision and a dream can reach the stars. In 2000, fewer than 1,000 satellites orbited Earth. Today, there are over 10,000, and more than half were launched by SpaceX. Starlink alone deploys over 6,000 satellites, creating the largest communications network in history. From farms to battlefields, everyone is watching. Startups monitor crops, weather firms track storms, defense agencies watch the skies. None of this would have been possible at $400 million per launch. New industries are being born above our heads. Orbital manufacturing creates materials impossible on Earth. Asteroid mining could unlock trillions in precious metals. Solar satellites promise endless energy beamed directly to Earth. The space economy is already hundreds of billions of dollars, projected to surpass $1 trillion by 2040 and maybe even $3 trillion. And it all rests on one foundation: reusable rockets. Falcon 9 proved rockets could be reused. Starship redefines them. SpaceX didn't just make rockets cheaper, it made space accessible, industrial, investable. Reusable rockets are more than engineering marvels. They are the foundation of trillion-dollar industries, new economies, and humanity's future beyond Earth. Thanks for watching my video. Please like, share, comment, and subscribe for more such videos.